Alright, welcome to my first combinational circuit video. This one is called the Big Even. Um, and we're given instructions to, of course, design a circuit called the Big Even. This circuit accepts the unsigned binary output from a 10-digit keypad and will output a high value only if the input is a number larger than 3. Is an even number larger than 3, that is. And so, um, basically what it's asking for when you really think about the question is it wants you to so you have four inputs. It only cares about, again, the inputs from a 10-digit keypad, and it's only one digit from the keypad, so it's basically saying, okay, 0 through 9. It wants to look at in a user input from a keypad 0 through 9. It wants you to turn that into unsigned binary, so we need to use 4 bits in order to express numbers ranging from 0 through 9. And so, yeah, so we take our 4 inputs, which I just arbitrarily named W, X, Y, Z, as you can see in this truth table here. This is going to be our output, Q. And because we need four binary inputs, we need to include all of the possible decimal numbers that can be created with 4 binary inputs. And that goes all the way up to 15. But in the question, we only care about 0 through 9. So for 10 through 15, we make them don't care conditions. We don't care what they are at all. They're not going to affect our algorithm in any way. It's just what we have to do when we create truth tables like this. And then it also wants, it only is returning 1 when the output, or when the input is equal to an even number that's greater than 3. So the even numbers in between 0 and 9 are 2, 4, 6, and 8. However, because it needs to be greater than 3, we don't care about 2. Or rather, we do care about 2, but it's just going to return 0 if the user inputs 2. So here we have 0 for 0, 0 for 1, 0 for 2, 0 for 3, 1 for 4, 0 for 5, 1 for 6, 0 for 7, 1 for 8, 0 for 9, and then everything else we don't care about. And so we took this truth table here and converted it into a K-map. And using this K-map, I created the product of sums and sum of products equations to find the simplest one. I found that the product of sums equation was simpler because it only uses 3 gates, whereas the sum of products equation will use 5 gates. And given this equation, I went ahead and mapped it out on Logisim Evolution. Yeah, so our equation is z complement z and w or x. And I got that by I don't know how much we're supposed to explain the K-maps, but I grouped this into 8, I grouped this into 4. So this results in not z, and this results in w or x. So it's not z, as given here, and w or x. There you go. And so we can test our inputs now. Oh, and just a little tidbit, that just means that y doesn't matter in our algorithm, which is nice. So now we only have 3 relevant variables. So I'll test all of the binary inputs now. So if we see for all zeros, it outputs 0. For 0, 0, 0, 1, outputs 0. 0, 0, 1, 0, outputs 0. 0, 0, 1, 1, outputs 0. 0, 1, 0, 0, outputs 1. 0, 1, 0, 1, outputs 0. 0, 1, 1, 0, outputs 1. 0, 1, 1, 1, outputs 0, 1, 0, 0, 0, outputs 1, and 1, 0, 0, 1, outputs 0. So there you go. And of course, all these are irrelevant. Doesn't really matter. So I've tested all of my inputs. I've shown you the truth table and the K-map. I've explained the thought processes and how I understood the question. And that concludes this video. Thank you for watching, and thank you for checking my website. See you next time.